Hi, today's main topic is what is address line part 2. Now, actually, what is the address decoding part 2? And I'm just gonna elaborate what I learned yesterday. So yesterday we just talked about the microprocessors and those kind of memory chips, right? So the 128 means that how many addresses it has and how many, I'm sorry, not many. What is the size of this? What size of the per address? And the microprocessor has 10 address, 10 address lines. So this is kind of question to make you to get an answer about how many chips we need, how many address lines to select the one chips, and how many address line we need to address its internal memory cells. And the first thing you have to know about this is the address lines is really hard concept. When first I encounter this kind of concept, it's really hard. But I'm gonna tell you, this is really simple. If you look at the computer, and if you're trying to open the computer and the hardware stuff, you were able to see some kind of the circuits, some kind of the memory, some kind of chip, right? And these are actually made of like circuits, of course, not gate nor gate and those kind of stuff. And there should be electric, and there should be line of the to connect the CPU between memory, right? And the address lines is among those. So what is basically address lines? Um, you know, computer can understand about 0 and 1 value. We have to fetch the data or read the data from the memory. So what computer do is just sending some kind of signals to identify it. And that is why address line is really important, because address line is a line for to get the value of this memory stuff. And yes, the address line is actually divided into two value, 0 and 1. Let's imagine you're going to drive a car. So example, this is the start line, and you're trying to drive a car. And let's say, example, you are like Elon Musk. You are pretty rich, and you have like multiple houses. You can buy any houses. You can decide how many houses you want to get, and you have some kind of size of the house. And actually, this is memory. This house is memory, and the starting point, the start is CPU. We are trying to get stuff from our house or memory, right? And we're gonna drive, and we're gonna use our road, right? And to go to your house, there's gonna be one way, or two way, or three way, or 1,000 way. If there's one way, it's gonna go here, right? But the thing is that in this one way, if you look closely, I'm gonna just draw the how the road look like, the driving road look like. In this one way, it's actually two. There's actually two roads in one way, which is 0 and 1. Yes, this is actually simplified address line using the example of using real world. And so which means that we're going to start, and we need to identify how many way we have to reach these some specific memory or house, right? And we have 10 address lines, which means that there are 10 of it, one way, two way, That's so early. Now just say times 10. So which means that this 0 and 1 has the 10 of it. And we can use the math equation, which is 2, 10. 2 over 10, so which means that 2 square 10, which means that we have 1024 location to reach there. And we have 10 ways to go there. And also, you want to specify how many way to accept to go to your house or memory. And actually, you can use this kind of equation. This is address. I mean, like kind of location thing. Not location, but how many way you can accept. And size is the size of your way of it. And to solve the how many memory I have using this kind of given specification is, it's simple. 128 times 8. And actually, in the computer science world and especially in computer architecture, we are commonly use the byte, 1 byte. So, and we can transfer this 8 bits into 1 byte. And the size is 128 byte. And so, which means that we have 128 byte of size of it. Pretty simple, right? And also, and we have to know about how many way it could have, because we just get the side of the house or memorize your memory, and given of this simple explanation, we can assume that this is the 10. So this x is how many address lines we got, right? So this x equals to 10. And next, we have to know how many lines we have, or how many ways to have to get single house. What I mean simply is, in computer science work, in computer architecture, the line, address line, doesn't mean it select just one chip. Your address lines can select the cell or so area inside your memory. So which means that we have to determine how many we have to get the internal cells, or how many address lines we have to get the single one chip. We have to decide that. And also there's an equation, the math equation of it. And we have 10, right? 10, right? And also, to start with, we have to also get how many the memory chips we have. And how many memory chips we have is really pretty simple. We have 1024 location, and we know the side of the house. Now, how many chips we need to have? We can just divide it into 128, and there will be 8. So it's gonna be 8 chips. 8 chips, yeah, 8 chips. And so we can just say 8 decoder, a Y28 decoder, and we can just say H equals to 8, and we can say like this. So our house is 128 byte, and we have 8 houses, 8 memories of it, 8 chips of it. And next, we have to know about how many lines we need to have to select the one the one total chips, one chip to get the size of it, rather than internal cells. And the simple formula is very simple, because you know the 8 chips, 8 house. So this is house or memory, right? 8 house. You have a 10 way, and you have 8. You have a 8 house. So how many other lines we need to have? It's kind of complicated, but it's very simple. We know that our road is actually 2 of it, right? And we can just assume that how the 2 square and 2 square, some kind of I equals to 8, because we are going to do the house. We are going to do the 8 house or 8 chips, right? And this means that log 2 and is actually equal to 3, and that means that we have 3 address line to get 1 chip. So that will be 3 to 8 decoder. Yeah. But how about the internet cell? How can we get the address line to get the internet cell, right? It is really simple also. If you look at here, we know that our memory chips has 128 areas or address. So this thing 128, and the address lines is actually 2 of it, and we can just use the log to 128 equals to 7, and that is the z gonna be 7, right? And rather than using this math equation, you can just divide 10 minus 3 because it is 7. So yeah, 7 is gonna be here, 7 here, and that's very simple. And this is actually the simplified explanation about how we get the amount of chips based on this kind of specification. And also, we're gonna go deeply rather than this. This is really simple background explanation, but rather we focus on this part, 3 to 8 decoder. Because our main topic is address decoder, right? And we have to know about what is address decoder. And you know, the address decoder is that there's actually the 2 strategies of it: full address decoding and partial address decoding. And what I learned was full address decoding, and we just know that we have 10 address lines, and we can just make it like this. This is devices. This is the memory chips, MEN1, 2, MEN7, because we have 8 chips, right? And also A0, A1, A2, A3, and A10. No, A9. This A is equal to the address line, so that means that this address line 0, address line 1, address line 2, address line 3, and if you're trying to add this whole thing, it's gonna be 10. Of course, because we have the microprocessor, 10 address lines of microprocessors. And full address decoding means that we actually knew that we just need three address line to get the one chip, right? So which means that we can just use these 3 address line rather than this 7 address line, because 7 address line is for the selecting the international, and the 4 address decoding. What I know about 4 address decoding is just ignore this stuff. We're just gonna use this part because that is not register, right? And there's gonna be 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, and blah, blah, blah. It's just a truth table. And more fascinating thing was, I look at how it gets this kind of truth table, and under the hood they're using AND gate or gate or NOT gate, and that was really fascinating. I'm just gonna try to explain the formula, how many AND gates we have, how we need to have to make a 3 to 8 decoder, and how many the NOT gates to make the 3 to 8 decoder. M to true M decoder, but we just knew that we have the 3 to 8 decoder. And the size of NOT gate and equals to the M, which is 3, and the size of the AND gate, not size, the quantity, the numbers, the AND gates equals to the 2M equals to 10, 8, right? So 8, and total gate is gonna be 3 plus 8, so that's gonna be 11. So we know under the hood we're using these 11 logic gates to make this truth table, and based on the truth table we were able to select the memory of it, because that is the decoder, right? So this is it. The reason why I was late, because I had to drive and I was really tired, and I was watching reels. I was lazy, so this is it. I know this is a really pretty hard concept, and I didn't figure it out how they make this kind of formula to get the quantity of this kind of NOT gauge or AND gauge of it. And so tomorrow I'm just gonna go deeply about how does it work, how we came from this kind of formula. We know the formula based on using this kind of house example, right, in the real world. I'm just gonna explain this kind of stuff similar with this. Have a nice day and see you next time. Bye bye.